Okay, this is 15.1.2, number 22, and it's the second of one of these applied volume problems. So we want to find the volume in the first octant. First octant just means it's a little bit like the first quadrant where x and y are both positive. The first octant for a 3D graph is where x, y, and z are all positive. And then it'll be bounded by these two curves. So this one first is just a cylinder of radius a that's centered at the origin in the xy plane, and it points along the z-axis. So that kind of defines our bounds of integration. And then the upper bound is z equals x plus y. So that's sort of the capping function that caps the whole thing off. That's not a 2, that's a z. Okay, so let's take a look at this first by examining this part. So again, this is a cylinder, so this is the z-axis coming out at us. This is x and y. And so it's bounded by just this portion right here. That's what I want my boundaries to be. So again, I'm going to draw these little rectangles in to indicate that's my integratable section. So my x is going to go from 0 out to the radius. So x will go from 0 to a. But the y is only going to go up to the bounds of that circle. And so we can solve for it right there. Y is going to also start at 0, but the tip of y is going to be equal to the square root of a squared minus x squared. And again, I know I only need the positive square root because we're only talking about the first quadrant. So everything's positive here. I don't have to deal with the negative one on the second octant. Okay, so there's our limits of integration, and there's the function we're integrating. So here we go. The integral from 0 to a in the x, and in the y, it's going to be 0 to the square root of a squared minus x squared, and the function is x plus y, dy dx. So first the inner integral, that's going to be the integral from 0 to a squared minus x squared under the radical of x plus y dy. And this one gets a little messy, like once we find the integral, which isn't too bad. The integral is just xy plus 1/2 y squared, evaluated between 0 and the upper limit, which is the square root of a squared minus x squared. Again, plugging this guy in produces a pretty messy integrand for the second stage. It actually turns out to be x times the square root of a squared minus x squared, and then plus 1/2 a squared minus x squared. So you can see with this as the argument for our next integral, that'll be the integrand right there. We're going integral from 0 to a. And this will be the first part, x square root of a squared minus x squared. This is actually going to have to be integrated separately from this. This one requires a u sub, so I'm going to stop there and say dx. And then we'll add on to it 1/2 and a second integral from 0 to a. And this one will be a squared minus x squared dx. This one's a little bit easier to process. This one's a little more complex. I went through and did the u sub for this one, and this one turns out to give you an answer of 1/3 a cubed. And ironically, this one does too. They both end up producing the same answer, which is 1/3 a cubed. So when we sum the two, we get 2/3 a cubed. And that's the volume of this unusual shape, which has, again, this will be a plane for its top surface, and it's actually a plane that sort of angles up this way, and then its bottom surface is a quarter of a circle, and therefore it sort of forms a cylinder with an angled top and just a quarter of a cylinder.